Hey again, guys. We are reading in our textbook today, pages 72 to 75. It's the whole section is air masses and fronts, pages 72 to 79, but we are breaking it up into two sections. The first section we're going to read about today is just the air masses portion. So we are going to go on with that. So starting on page 72, we're going to skip the discover activity and scoot down here. Listening to the evening news in the winter, and you may hear a weather forecast like this. A huge mass of Arctic air is moving our way, bringing freezing temperatures. Today's weather can be influenced by air from thousands of kilometers away, perhaps from Canada or the Pacific Ocean. A huge body of air that has similar temperature, humidity, and air pressure at any given height is called an air mass. A single air mass can spread over millions of square kilometers and be up to 10 kilometers deep. And so what you end up having is you have this air mass that will have similar properties. It'll have similar temperature, like it said, humidity, meaning the amount of water in it, and air pressure. So it sort of has this similar density and temperature and whatnot, and they can be massive. The thing about it, as you guys remember about mixing different substances of different densities, like if you try to mix oil and water, because they have different densities, they don't mix very well. And air masses are actually kind of like that. They sort of stay to themselves and then they meet along these areas called fronts. We're going to focus today mostly on identifying and naming the air masses in this section. All right, going on to types of air masses. Scientists classify air masses according to two characteristics, temperature and humidity. There are four major types of air masses that influence the weather in North America. You have maritime tropical, continental tropical, maritime polar, and continental polar. Now, these words, the word maritime is like marine, or the Spanish word for sea is mar. So, maritime, marine, those all have to do with the sea or the ocean. So, if you see the word maritime, you know that that is going to be an air mass that contains more moisture. It's going to be a wet air mass. You know the word tropical. Tropical should mean warm. So maritime and tropical would be a warm and wet climate like you're seeing here. Continental is like continent or land. So when you see the word continent, you should think dry. So continental tropical would be a dry, warm air mass. As you see here, dry and warm is continental. Maritime, that word again, meaning it has more moisture. So maritime polar, and polar, of course, meaning cold. So maritime polar means cold and wet. So you can see that here, maritime polar. And then continental polar would be, again, continent is dry, polar is cold. So dry and cold. The characteristics of an air mass depend on the temperature and moisture content of the region over which the air mass forms. So if it forms over land, it's going to be dry. If it forms over the ocean, it's going to be wet. If it forms in a tropical region or near the equator, it's going to be warm. If it forms near the poles, it's going to be cold. Remember, the temperature affects air pressure. So cold, dense air has a higher pressure, while warm, less dense air has a lower pressure. Tropical or warm air masses form in the tropics and have low air pressure. Polar or cold air masses form north of 50 degrees north latitude and south of 50 degrees south latitude. Polar air masses have high air pressure. Whether an air mass is humid or dry depends on whether it forms over water or land. Maritime air masses form over oceans. Water evaporates from the ocean, so the air can become very humid. Continental air masses form over land. Continental air masses have less exposure to large amounts of moisture from bodies of water. Therefore, continental air masses are drier than maritime air masses. These are the four air masses. We're going to talk about them each individually. So maritime tropical would be a warm, humid air mass. Warm, humid air masses form over tropical oceans. Maritime tropical air masses that form over the Gulf of Mexico and the Atlantic Ocean move first in the southeastern United States, and there's a map on the next page we'll look at. These air masses then move north and northeast, where they influence weather in the central and eastern United States. In the west, maritime tropical air masses form over the Pacific Ocean, because that's the ocean over there. They mainly affect the weather on the west coast, California, Southern California, Mexico. As they cross the coastal mountain ranges, the Pacific air masses lose moisture. As those clouds sort of move inland, they end up losing a lot of their moisture. And once they get to the mountains, there's less moisture, and the warm air will go over, but the humidity stays. In summer, maritime tropical air masses usually bring hot, humid weather. Many summer showers and thunderstorms in the eastern United States develop in air masses that have formed over the Gulf of Mexico. So thinking about like those tropical storms that they get in the south in Florida, along the lower east coast of the United States, near the Carolinas. Louisiana, things like that. So many summer showers and thunderstorms in the eastern United States develop in air masses that have formed over the Gulf of Mexico. In winter, a humid air mass can bring heavy rain or snow. And here's that map that I was talking to you guys about. I'm going to zoom out here. So you can see in this, you can see we have over here is the upper west coast of the United States. And this is where we're going to get that maritime, because it's forming over the Pacific Ocean, but polar because it's in the northern part of the northern hemisphere. So you get maritime polar air masses from the Pacific Ocean bring cooler, humid air to the west coast. And Seattle is known for cold, rainy weather. Maritime tropical air mass down here in the southern coast of California. So it's maritime, meaning it's moist air, and tropical, meaning it's warm. They bring air masses form from the Pacific Ocean, bring warm, humid air to California and the west coast. I'm going to go all the way to the other east coast because, again, we have these maritime air masses still. So maritime, again, because these now are forming over the Atlantic Ocean. Polar because it's in the north, and that affects their push out to sea. And then southern maritime tropical air masses here form over the Gulf of Mexico, and they bring that warm, humid air mass up to the coast here. In the middle here, though, both of these air masses are continental because they form over land, so they will be dry. And you guys have heard we had the polar vortex a few years ago. That cold, dry air was coming down from Canada. That was coming down from central and northern Canada to bring cold air to the central and eastern U.S. And then the continental tropical would be a dry air mass coming up from the south. So these go into like Arizona, places like that. Maritime polar. Cool, humid air masses form over the icy cold North Pacific and North Atlantic Ocean. Maritime polar, again, wet and cold air masses affect the west coast more than the east coast. Even in the summer, these masses of cool, humid air often bring fog, rain, and cool temperatures to the west coast. Again, that's like Northern California and Seattle. Continental tropical, hot, dry air masses form mostly in the summer over dry areas of the southwest and northern Mexico. So continental means dry and tropical means hot. Continental tropical air masses cover a smaller area than the other air masses because we have a lot of coast in the United States. They occasionally move northeast, bringing hot, dry weather to the southern Great Plains. Continental polar. Large continental polar, so dry and cold air masses form over central and northern Canada and Alaska, as shown in Figure 3. Air masses that form near the Arctic Circle can bring bitterly cold weather with very low humidity, so dry. In winter, continental polar air masses bring cold, clear, dry air to much of North America. In summer, the air mass is milder. Storms may occur when continental polar air masses move south and collide with maritime tropical air masses moving north. Like I said, because these air masses have their own temperature, humidity, and pressure, they have their own density. So they don't mix very well. So that's why you might get storms that occur where continental polar air masses, so these cold, dry air masses, will meet a warm, humid air mass. Okay? How air masses move. When an air mass moves into an area and interacts with another air mass, it causes the weather to change. In the continental U.S., so that's the 48 states, air masses are commonly moved by the prevailing westerlies and the jet streams. We've talked about these air masses, and we've talked about these wind bands. The prevailing westerlies, the major wind belts over the continental U.S., generally push air masses from the west to the east. For example, maritime polar air masses from the Pacific Ocean, so west coast, are blown onto the west coast, bringing low clouds and showers. Embedded now, those jet streams are embedded within the prevailing westerlies, are the jet streams. Recall that jet streams are bands of high winds about 10 kilometers above the Earth's surface. As the jet streams blow in from the west to the east, the air masses are carried along their tracks. Where they meet are things called fronts. As huge air masses of air move across the land and the oceans, they collide with each other, but they do not easily mix. Think about a bottle of oil and water, like we said. The less dense oil will float on the top of the denser water. Something similar happens when two air masses with a different temperature and humidity collide. They do not mix, but the boundary where the air masses will meet becomes a front. And because you have this colder, dry air mass meeting with this humid, warm air mass, it causes cooling, it causes condensation, lots of cloud formation. You can get lots of clouds, storms, and changeable weather often develop along fronts. And you have a picture here. This is a pretty crazy picture where you have this cold, dry air mass, this warm, moist air mass. And we know it's moist because you can see it has a big cloud. It's carrying moisture in it. When the cold air mass meets that warm, humid air mass, that area in front is called a front. And the colder, denser air will move under and push the warm air mass up. We will read more about fronts in our next section. Bye, guys.